Alright, so in this video we're going to be going over my project experience with this OpenRC F1 car and what it's taken to meet my one goal of running an entire battery pack through this car without breaking something major. Now, let me just start this out by saying that I started building this way back in 2020, early 2020 at that. So this project has been in the works for over 2.5 years, and I've been wanting to make a video on it, but it's just been a real struggle getting this car to something that I feel like I can present. And it's still not 100% perfect. There's still things that I need to fix on it, but I've had just major problem after major problem with this thing, and we'll get into that later. But if you don't know, this car is fairly popular in the 3D printing community, but this was designed by Daniel Nere, and it is a fully 3D printed RC car, which in itself is pretty impressive. The only thing that's not 3D printed on this, obviously the electronics and a few screws here and there, but all of the parts, including the stock tires even, are 3D printed. Now, I built this car for two reasons. The first reason was I wanted to see how far you could push 3D printed parts in an RC car application like this. I felt like it was a very functional application of 3D printed parts, and I just wanted to see how durable it would actually be and how fast you could make a car like this. The other reason was I wanted a different RC car. There's an asphalt track kind of near to my area, and I wanted something to run on that asphalt track besides my big 10th scale monster trucks, because those just don't really do super well on an asphalt track. And the curiosity for building something like this or seeing how far you could push this kind of came from a video I did a while back, well, around the same time I started building this car, actually. But I did a video making a Traxxas spur gear on a 3D printer, or a mock-up of one. And that spur gear lasted a surprisingly long time. In fact, it never actually got worn out before it was eventually replaced with a part once it became available. But I was impressed with how well that cheap little PLA gear handled the torque of what I would consider a fairly powerful motor in a car that can travel at 20 or 30 miles an hour. So this project came about, and it has had many issues. But let's go ahead and take a closer look at the car, and I'll kind of discuss the experience I've had and why this thing has taken so long to make a video on. Alright, so here we have the car. First, I'll give you some basic specs. So the tires are the recommended Tamiya replacement tires for the 3D printed ones. So these are real RC car tires, which give you quite a bit more grip than, say, like a Ninja Flex printed tire. The electronics are pulled out of a Traxxas Stampede 4x4 VXL. So this is one of the older two-pole brushless Valenion systems. So that's a 3500 kV 1/10 scale brushless electric motor. Fits in there pretty well. The rear dust cap has to be taken off for it to fit in this shell, but it works out reasonably well. The receiver is actually completely custom. So the receiver and the transmitter both are completely custom. So this receiver consists of an NRF 24L01 Plus module. This one's one of the little low power guys. Well, I guess standard power, I should say, not low power. And then underneath this is a custom circuit board, which is just running a ATmega 328 processor. And it's effectively just a breakout board for the NRF 24L01 module and then two servo connectors. And this header on this side is the serial programming interface. So I'll plug that back in. One design mistake with this board is that the radio module plugs in and covers up the two servo ports, but I've gotten around that by using right angle pin headers to connect the ESC and the servo. And then the servo is just one of the really cheap blue 9-gram servos that you can get pretty much anywhere. The steering is one thing that I do want to upgrade on this eventually, because those little plastic geared 9-gram cheap servos are really really bad for this kind of application. They're probably okay on, say, an airplane where you're only moving just a control surface up and down, but on something like this where the wheels can get knocked around if you hit a wall or something like that, they're really good at breaking the gear teeth. Now, originally, I didn't start off with this brushless power system that I mentioned earlier. I was using a brushed Traxxas Titan 12-turn motor and the matching ESC for it. There were two things I didn't like about that power system. Number one, it really didn't fit in here. The Titan 12-turn motors are a 550 size motor. This is designed to take a 540 size motor, which ended up meaning that the terminals ended up sticking out of the side of the case over here, and I had to cut a big slot where the motor was so the wires could actually be hooked up to it. The other thing I didn't like about the Titan 12-turn was that the brakes were way too weak for this car. That motor just really isn't designed for this sort of an application. Neither is this one, but it would be a lot better to have a lower RPM motor. Both the Valenion system that's in here and the Titan 12-turn are more optimized to rotate fast, and they're meant to have much higher gear ratios between the wheels and the transmissions. Now, the footage that I've probably shown you in editing of this thing running around at the track that was all filmed on one day. That was the one time that I managed to chuck a battery into this thing and just drive it. Speaking of the battery, this is the battery in question. It is a really small Gens Ace LiPo 2200 milliamp hour 2S pack, rated at 45C, so plenty of punch for this little car. So I've mentioned that I set a goal about 2.5 years ago to be able to run through that entire little battery pack without having to do any major repairs to this car. So you may be wondering, why has that been such a huge challenge? The first issue that I had was breaking parts. These 3D printed parts really do not withstand impacts, and I've done a couple things to mitigate that. First off, the front air splitter, there's probably a proper term for that, but this piece is made out of TPU. It's the 95 shore hardness stuff, so it's pretty stiff still, but it's a little bit softer, so if you clip a wall or something with, say, the front corner like that, you won't immediately shatter this part. Same thing with the back wing here. This is also inflexible filament, so if you spin out or whatever, tap a wall, this won't just immediately fly apart into a million pieces. The rest of the components on this are PETG, so all of the red. I believe all of the black parts are PETG too. Some of these base plates may still be in PLA, I can't quite remember, but I believe everything on this is PETG. So that was one issue, and even while I was out the last time and I got a successful test run, I ended up breaking 3 of these nose cones, because if you hit a wall like that right on the nose, it likes to break right there. And I actually ended up breaking this little tiny piece of plastic back here that is responsible for holding in this pin, which keeps the roof on it. So unfortunately I had to replace this entire piece as well from that. So other parts that break on this all the time, the axles. The axles have been a major issue, whether it's the front axles or the rear axles. The front ones look like this. So these are a fairly small little piece of plastic for what they do. And the real problem with these is that they get printed standing like this, and you end up with the layers going this way. So when you turn them like this and insert them into the part in the car, which is the one back here, you end up putting all of the load right on the layers. And of course, when you do that, you're using the weak part of the print in order to support the car, and that doesn't end up working all that well. So it's pretty common to hit like a little bump or a rock or something like that and just have this shear off and one of the front wheels just kind of bounce off into the distance. I should also mention the wheels are mounted on bearings on this. You can kind of maybe see the bearings in there, but there's one bearing on each side of the wheel, so you insert the bearings into the wheel, slide the wheel over the axle, and they roll pretty nicely. So you're not just rolling the wheel on plastic. So I tried a couple things to keep these front axles from breaking. One of those was to print them in TPU because I thought, well, there's two reasons why I thought that TPU might work better. One is that it should flex a little bit more when it takes an impact. And the other thing that's cool about TPU is it has really excellent layer bonding properties. Of course, making the axle flexible kind of has its own issues because you start having weird alignment issues with the bearings and whatnot, and they ended up breaking anyway. I believe these print like this by default, so the small end's stuck down and then it's like that, and that's nice because you don't need any support, but like I already mentioned, it's not that strong, so what I ended up doing was just rotating them so they print like that and putting support material on them, and that ended up making for a much stronger axle, and I haven't had issues with those axles since. Now the rear axle has a similar sort of issue, with the exception that it does print in an orientation that already makes sense. So there's not really a whole lot you can do to make that axle stronger. I tried printing it in many different materials. I tried PLA, I tried PTG, and I tried ABS even, and I couldn't get any of them to hold up. The ABS ones I think did the best, but in the end, what I have in here is a machined aluminum part. So this part was made on a lathe, and the slots for the gear on this side and the wheels were cut on a mill. And that made for obviously a way stronger axle than what you get with 3D print. So that solved the issue with the wheels always flying off. Another issue that it had were the stock gears, or the gears that you're supposed to print for this thing. The pinion gear would last probably all of 5 or 10 minutes of driving, and the spur gear wouldn't last too much longer than that. The plastic gears on this car just did not hold up with the powertrain that I had in here. Is that because I'm trying to overpower this car? Probably. If you stick with the recommended motor and electronics combo that this thing is supposed to have in it, you'll probably have a much better time with that. So instead of running the plastic gears like what this is meant to have on it, I changed to running the original spur gear that was on this motor in the Traxxas car, which is an 11-tooth 48-pitch gear, and I designed and printed a matching 48-pitch spur gear. I can't remember the exact number of teeth. We'll have to look into that. I think it's 60, maybe it's 72, somewhere in there. Now, to be honest with you, this is still a fairly low gear ratio considering the motor that's in here, and I very rarely go above half throttle with this because it has way too much speed to be really controllable. Another issue that I've had is the steering. The steering's had numerous problems. A lot of them are around the fact that there's a lot of slop in the mechanism, and that's probably partially because I don't have a very good linkage between the servo and the wheels, but the cheap servos didn't help that, and the other thing that I had a lot of issues with was the servo saver. Now, servo savers are pretty common on RC cars. The idea is that if you hit a wheel, the servo saver is supposed to move before the servo gets broken. But I found that the servo saver on this car has way too much slop in it. So I ended up actually going in and fusing the two halves of the servo saver together in a 3D editing package and just made it one piece. And with it one piece, you couldn't have the two parts rattling around and causing all kinds of issues where your wheels are just flopping all over the place. Even so, the last time I went out to the track, just about every time I hit a wall somewhat hard, I would end up bending the little rod that I've got connecting the steering wheels and the servo. And the servos themselves I've gone through a few of because the gears are pretty weak and they're just really cheap servos that like to flake out even if you don't put them under a whole lot of load. So it'd be a lot better if I had a good servo for it. And finally, the last problem that actually just came up the last time I had it out is these rear wheels. Now, I probably did this damage sometime in the past, but I started noticing while I was driving around at low speeds that I could hear this squeaking sound, and I wasn't sure what it was coming from because all the bearings in this are relatively new. My default assumption was still bearing, but what it actually is these wheels turn, especially this one, the wheel turns on the axle. So the little notches that are supposed to keep this wheel held in place while the axle spins were no longer doing their job. And I think that may have actually been part of my steering issue, because what would happen was when you touch the throttle, you would end up veering off in one direction fairly uncontrollably and unpredictably. And what I believe was happening is that this wheel was starting to slip and the other wheel was catching it, and you end up with one-wheel drive and the car wants to go this way. Now, granted, if I hold the gear and turn this wheel, it still slips too, but it's not as loose as this one is. So it's going to need new rims for these tires, which of course is a bit of an undertaking because I have to unglue these tires to get the rims off. But it is possible to do. Alright, so all in all, this project has been kind of a pain, but it's mostly been my fault because I've been trying to shove way too big of motors and way too much power into them. And I've been trying to use the really cheap servos. Basically, all of my problems have stemmed from not wanting to pour enormous amounts of money into this car and using parts that I've already had laying around from other RC cars and other projects with those little servos. So that's a pretty decent overview of the car itself, but let's take a little bit more time to look at the electronics that are involved in this. Alright, so we'll take a little look at the circuit board here, and this is actually the first time I had ever built a circuit board. Now, this particular one that you're looking at is revision 2. Revision 1 was pretty similar, except for I had put level shifters for this little NRF board. I kind of completely forgot that you don't actually need to use level shifters for these. And the reason for that is these are 3.3 volt devices, but the I/O pins are 5 volt tolerant, so you don't actually need to use a level shifter for them, which is nice. This is the board itself. It's focused around an ATmega 328 PB. The PB is a little bit different than the standard 328. The pinouts are just slightly different. A couple of the power and ground pins, I believe, are in slightly different locations, so not quite the same as your standard Arduino Nano chip. And I didn't realize that when I ordered them. That was the other reason I made a V2, was because these chips weren't compatible with V1 because I designed it for a regular ATmega 328. Now, the power for this board comes off of the electronic speed controller for the motor, or the ESC, and that gets fed back through the black and red wires here. Now, that power is 6 volts, so it's a little bit too much to run this, and it's definitely too much to run the RF module. So there are 2 regulators on this board. One's 5 volt, one's 3.3 volt. That's what those 2 guys are. And then it's just the standard crystal oscillator. There are 2 LEDs on here, D1 and D2. Those guys can be controlled by the microcontroller. And other than that, there's a couple of extra pins broken out on the sides. There's the ICSP header over here. And that's really about all there is to it. I guess there is also another servo connector on there if I wanted to run 3 servos. So this is the transmitter that goes along with the receiver. This is a heavily modified Traxxas TQ transmitter. Originally, it would have operated on the 27-ish megahertz range, and it had a probably about a 4-foot long antenna that you could stab your eye with really easily. Only did that once or twice, but anyway, this was kind of another part that I just had laying around, and it was also another source of issues. And this issue, or the main issue that this had, was the potentiometer for this steering wheel here had gone bad, and it was starting to get really bad connections. It was really flaky, and it was really hard for me originally to determine whether that was a problem with this transmitter, if it was a problem with the cheap servos, or if it was a problem with the software that communicates, or the software that sends data between this transmitter and the receiver. So eventually I got that figured out, that it was the transmitter, and I ended up having to buy a whole nother transmitter off of eBay, which I think cost me like $20, and I stole the steering wheel unit out of that transmitter and put it into this one. So yeah, that probably wasn't really worth it to buy one of these just for the transmitter, or just for the potentiometer in here, but anyway, it's done. This also has been modified to have an extra switch in here. And this isn't used for this RC car. It's actually meant to be used for another project, which maybe we'll get a video on that eventually. But in terms of transmitting now, this runs on the 2.4 gigahertz band, of course, and it's using one of the larger, higher power NRF24L1 modules. So power switch down here in the same location that the original power switch was, and we've got a power LED in the same location as the original power LED. On the bottom, there's this 3D printed cover, which goes over where the battery is, and it's pretty terrible. It's just glued in place. But we'll set that off to the side. And then on the inside, underneath that cover, we have a battery box and a piece of perf board with an Arduino on it. So this guy takes 4 AA's. So there's not really a whole lot on this board. It's just an Arduino Nano plugged into a socket with voltage regulation on it. So all of this is running at 3.3 volts. I didn't bother trying to make the Arduino run off of 5 volts. It doesn't really matter. The whole thing can run off of 3.3 without too much of an issue. And then everything else is just a mess of wires that runs up into the top part of the transmitter. The one kind of neat thing about this is that this board slots in quite nicely to the little slot that's already around the case, which I think was there for maybe the battery tray. It must have been somehow for the battery tray that used to be there, but it holds the board in pretty nicely. Now you may have seen that mess of wires and started wondering why there's so many when there's only 2 potentiometers here effectively. Well, if you start looking at this transmitter, there's actually quite a few things that are going on. There are, I believe, 7 wires that have to run up to the NRF board in order to power it and send data. Both of the steering and throttle trim knobs do work, as well as, of course, the steering and throttle. And then there's also some extra wires going down for this switch here. So everything on this pretty much operates exactly like it would on the original Traxxas transmitter. The only exception is the throttle trim knob doesn't work because it's not set up in code. So turning this won't actually affect anything, but the ability to make it do something is there. It's wired. It just isn't set up in the code. Steering trim does work. This switch is kind of in the same boat as the throttle trim knob. It's set up in wiring, but it's not set up in code. And the antenna folds down like that for easy storage. So overall, if you're going to build one of these, I would highly encourage you to use the servo and motor that are recommended by the designer of this car, not just chucking in the biggest thing you can possibly find. Now, I think if I can get the steering perfectly sorted out and obviously fix the wheels so that they deliver power properly, I believe this car will go incredibly fast and be relatively controllable. I think the only limitation with that is going to be the suspension, because this thing does like to bounce around quite a bit, because there is no suspension on this car. It's completely stiff minus the little bit of flex in the plastics. So that's another limitation with this car. But anyway, it's a cool little project. It's certainly cool to look at. It's a good conversation starter at the very least. I have this thing sitting on a shelf in my living room right now. Anyway, that's about it for this project in this video. So I'll see you in the next one, guys. Bye.